Okay, we probably have enough people to at least get this started. There's someone from Geth. Is anyone from Nethermind here? Oh, Vitalik, have you joined Nethermind?
I have not joined Nethermind.
Okay, I saw. Okay, we have at least Hamad. Okay, let's get this started. Welcome everyone to ACDE 169. So some Denkun stuff today, getting some updates on Devnet 8, and then we can continue the conversation around the testnet ordering. Then Andrew wanted to bring up the Verkle try and state expiry strategy, so we can spend some time discussing that. And those are basically the two big things. After that, I think Ethan just had some updates on SSD he wanted to share, and that's pretty much it. I guess to kick it off, do we have Barnabas, do you want to give an update on Devnet 8?
So Devnet 8 has onboarded all the different clients, and everything looks very healthy. We have a few of the pairs that are not really working. Yesterday we had a smaller issue with Nethermind. Hopefully someone from the Nethermind team is here to let us know what has happened. I'm not quite sure, to be honest, but we see quite some drop. But then they released a new version, and after I rolled it out, everything went back up again. And
nice.
We have a few pairs, as mentioned, mainly Aragon and Ethereum JS, that are struggling with a few of the CLs. We have now a Beacon Chain Explorer also onboarded, and we have a light Beacon Chain Explorer also. I will share the links in a second.
Sweet, thank you. Does someone from Nethermind want to give some context on the issue that was fixed?
So I'm not entirely sure because I wasn't involved, but as far as I know, the experimental transaction pool stuff was merged and was causing problems, and it was like missed that it was merged, and so yeah, so that's basically it. So the transaction pool part that we have separate for transactions was causing problems. It's not yet ready.
Got it. So was the fix just to revert that change rather than having a full working transaction pool?
Yes, I think so. So I think Marcin will handle that soon.
Got it. Thank you. Any of the other clients want to share? Context on any issues or fixes they've made this week? Okay. And I guess before we go into the test nets themselves, it seems like we probably still want to get more testing done on Devnet 8. Does it feel reasonable to try and get all of the pairs working on Devnet 8, and then once we have that, move to Devnet 9, do the last changes with the 4788 spec, and hope all the pairs sort of work on that pretty smoothly?
I personally think that's reasonable, and I'm just curious if we had an agreement on how to deploy the contract.
So we we decided we're just going to use a normal transaction, and if I remember correctly, the reason was it was pretty split between that and the custom deployment logic, but we figured a normal transaction was easier to implement and just start with that, and then if for whatever reason there's like issues with using the normal transaction, you can always add the logic around the in-fork deployment. Oh, sorry,
Would
Barnabas.
there be any hype test for this?
Good question. I don't know, Mario. What do you mean by
just? So there is going to be like a particular address that needs to be sent from. It's like a synthetic transaction in that it's reverse engineered from a particular. I actually don't know exactly how it works. I'm not going to explain it. But there will be a particular address that needs to be funded to do the deployment. And there'll need to be a big enough gap between, Genesis and the fork on that testnet such that we can do that. I think we normally have such a gap, but it's just going to be something that we manually need to make sure is done in that interim, and not to just for this testnet, don't just deploy it to a particular memory location at Genesis. We want to do the actual transaction. The spec, it's mentioned how to do so in the
EIP.
in the actual spec 4788. Yeah.
Okay.
That's why it has a particular address.
Got it. And I assume
that the client teams can.
Oh, sorry. Go ahead.
Implement quite quickly.
Just so one person has to do this.
Okay.
Right. This is not in the client.
Like one person, maybe Matt or other, should, write a script or just do it themselves if it's not worth to be scripted. It's just a couple manual steps.
But I assume for stuff like Devnet, we would need to have this then deployed on the actual epoch of Denkun.
No, it has to be deployed before. So that's why I said there needs to be an adequate stretch between Genesis and Denkun. It's because a manual transaction has to make it on chain.
Mario?
Yeah, so I guess we can just add the expected address in the Devnet Genesis, and also the tests, just to match what the address is currently in the EIP. And yeah, instead of sending the transaction. And that's the reason I asked if we were doing a normal transaction or this transaction, because with this transaction, we have a deterministic address everywhere. And it's just easier. But yeah, for the tests, I assume we're going to update the address to the final address we are seeing in the EIP for Devnet 9, if that's okay with Barnabas and Barry. Yeah, we can do that ASAP if you guys want.
And
yeah, so
importantly, yeah, go on, sorry.
I was just gonna say, yeah, as long as it doesn't affect any. So I guess as soon as you change it in Hive, those tests will start breaking for clients. And obviously we shouldn't retroactively change this on Devnet 8, but yeah, going to Devnet 9, we should make sure that Hive reflects this address.
Yeah, I will just send a message, and when we get sufficient go ahead from every client, I will just update the Hive test.
Mario, can you make sure that there are Hive tests where this contract is not deployed in time to that address? Just that's something that almost certainly won't happen, but it's something that can happen in this technique. So I just want to make sure that we do test the kind of like no op at that address. It should quote just work, but we should have tests.
Yeah, absolutely.
And so there was a question by Barnabas in the chat asking if client teams are ready for Devnet 9. And I guess based on the comments by Nethermind, should like, do we want to figure out the full blob transaction pool on Devnet 8 and potentially test that on Devnet 8 before we deploy Devnet 9? Or would we want to move to Devnet 9 sooner rather than later so that we can have the final 4788 spec and then maybe do a bit more non-consensus changes on that Devnet? Joachim?
Hi, yeah, sorry. I just want to ask like about EIP 4788. For Devnet 9, do we also want to add the beacon contract as a warm address or not?
You say
The
a
beacon-
burn address?
A warm address. So like it is a sort of a pre-compiler. But do we want to add it as warm or not? I'm not sure if this is the right place to ask this question, but do we want this or not? Because I know this question has been raised before on the R&D.
So this is the deposit contract, whether we should always treat it as a warm address?
No. So the beacon block root. So the new contract.
Oh,
Matt says, I think we decided no.
Yeah. So okay, then that's fine. Then yeah.
okay. And I guess, so back to the Devnet 9. Oh shit, I was muted for everyone on the stream. Sorry about that, everyone watching the YouTube. I can try and swap with the Zoom recording later today. Back to Devnet 9. So do we want to get it live as soon as possible, or do client teams want to make sure that things are working, that we have like the Blob transaction pool on Devnet 8, that we maybe spam Devnet 8, send some bad blocks on it and all of that? Yeah, how do people feel about moving to the next one versus doing more testing here?
Assuming there's no spec change other than the way this contract is deployed, I'd rather be very confident going into DevNet 9 rather than like saying, okay, well, we hope these things are going to work. And so in that case, I'd rather iron out the things that we know are issues. Otherwise, if we have a high chance of issues in DevNet 9, then we certainly will have a DevNet 10. And I'm not saying we shouldn't have a DevNet 10. We should have the amount of DevNet that makes sense. But I think at this point, we can like attempt to have DevNet 9 be like really solid.
Yeah, I would also lean towards that, unless people think there's like some reason to test the 4788 change much sooner. Yes, FLCL.
It looks like the current DevNet, well, clients have several quite critical issues. Like we have a different opinion about how to calculate block hashes, which is quite a basic stuff, right? And we're observing preloads, new preloads with some kind of wrong data appear. So maybe we could at least make it more stable and fix all of that, because the network had multiple forks as far as I know. Now it seems more stable, but this issue is still exists, and I think it will cause a lot of troubles if we do another network. Maybe we could spend more time on stabilization.
I also just want to echo, like I believe, and I think most people on this call believe, that like the deploy method for 4788 is like almost a no-op for clients, and so I don't think we need to rush to test that spec change. Like it really doesn't manifest as a change to them. It's obviously something we have to test, but stability and reduction of additional overhead and Devnet, it seems to be the preference.
Okay, so yeah, that seems pretty widely agreed upon. So let's move forward that way, and obviously we'll check in on both the CL call next week and then this call in 2 weeks about Devnet 8 testing, and we can use that to inform when we launch Devnet 9. And I guess so the next thing, so you know, once we're kind of feeling confident with the DevNets, whether that's after Devnet 9 or, you know, potentially if we need more after that, we started discussing the ordering of testnets on last week's call. And I think it would be good to start to align on the order, just because we're going to want to announce the launch of Holsky, the deprecation of Gordy and all of that. So even though we don't need to like talk or decide on dates or anything now, yeah, I'd like to just get a feeling from like, what do people think is the right order for them? My proposal was starting with Holsky because it's basically new, no one will be using it, and I assume there'll be like a pretty controlled set of operator at Genesis. So it's not a huge group to coordinate to upgrade the testnet. Then I would probably do Gordy if this is the last fork we're going to do on the network. I guess the risks of breaking it are slightly lower in a way. And it's also good because most of the applications, and especially the L2s, run their testnets on Gordy, so it gives them a tiny bit more time to test. And I would finish with Sepolia just as a final sort of dry run before mainnet. And by then we'd obviously expect to no longer have any sort of issues. Yeah, does that generally make sense to people as an ordering? Do people have preferences or different preferences than that?
Makes sense to me.
Okay, yeah, no objections. So if that's good, we'll probably have a blog post announcing that Holsky went live once it's actually been launched, and you know it's relatively stable. In that same blog post, we'll also mention that this is the last fork for Gordy. And finally, as well, there's been some folks working on Ephemery, which is a DevNet that keeps, or sorry, a testnet that keeps restarting at Genesis for stakers to test their setup. So we'll start mentioning that as well, but it's still semi in development. So we're not going to use it as like one of the main testnets or anything, but we'll at least let people know that they can test validators on it and have like a quicker iteration cycle.
Is the cycle 1 week or 2 weeks? Or
I always forget. I think it's on the website. Let me check. Oh, I can't find it super quick. I don't know. Is Mario on?
It's not a good job. I can figure it out.
Yeah. Sweet. And then Barnabas, you had a PR, I guess, just changing the time on Holsky for basically removing Cancun until we figure out the time. Is that right?
Yeah, that's correct. So apparently everyone would have an issue overwriting the Cancun time if it's already set once.
Okay.
So this is something that maybe some clients will have to change, but the PR is still open. I would just want all the EA to, approve it before I merge it in, because it can potentially cause some issues, especially for Aragon users.
Sweet. Anything else on testnets or Cancun?
One more thing that I also think that Holsky should be the first one going into Denkun, and we should really stress test the 3 and 6 blobs that we have set up. So it's going to be a very good test to see if we can handle it. And after that, we could adjust if needed down to 2 to 4. Or if it's deemed reasonable, then I think we can leave it as is. Because at 1.5 million validators, if that can handle it, then it should be good for the mainnet too.
The heads up, adjusting down would be a hard fork. And so I'd rather, if we did deploy 3.6, I'd rather just leave it as is or reboot the net than having like an hidden hard fork for that testnet.
I'm not saying that we should like hard fork Holsky. I'm saying that we could probably adjust it down for Gurley or Sapolia.
Yeah, got it.
Right, but would that mean?
But
I know on the CL, I assume you can probably set all of this in the presets on the CL. I don't know if on the EL this would mean we have to maintain 2 versions of the code paths based on the network. So I don't know how easy it is for the CLs to support different blob counts by different networks.
You mean the EL? How easy
Yeah,
is
sorry,
it?
yes. I assume it's easy on the CL. I don't know if it's easy on the EL.
It seems like a configuration parameter, but sometimes things go deeper than that unexpectedly.
Yeah.
Is there any reason we wouldn't want to fork Holsky also down to 2.4?
Right.
That would certainly be exceptional code path at that point, because you need conditional logic to change the configuration dynamically. And so I would definitely not advocate for, even if it's not the parameterization we go with, I think you either keep Holsky at a higher or you get rid of Holsky and start over.
I think, Justin, you're going to say something about the EL side?
I think Danny's got me covered. I was just saying that for Besu, at least, it's more of a protocol schedule concern than a configuration concern for us. So it would be work, but it would be non-trivial work, but it wouldn't be hard.
Okay, so but it would be better to keep Holsky at 3.6 no matter what, even if we make all the other Devnet or all the other test nets and mainnet 2.4, right? Then rather than having a special fork just on Holsky that goes from 3.6 to 2.4.
It would be easier. I wouldn't say it's better, but yeah.
Okay, yeah.
So just a heads up, we do have the schedule to talk about next week. Again, the mainnet parameterization. Some new information presented about big blocks on mainnet, and just to reopen the conversation, as you know, it's a default in our parameterization, but we've all agreed to talk about it again. So we can obviously talk about it more here, but before even deciding if Holsky is going to go 2.4.3.6, we should decide if we're going to if we want mainnet to be such before we go to this testnet. So next week is good too. Sorry, I was wearing my hat. When I wear my hat, you can't hear me. It is not a tinfoil hat.
Yeah, it's better without the hat. Cool. Okay, so I think I got the gist of that. We're going to talk about it more on the CL call next week, and there's some interesting data based on seeing larger blocks on mainnet right now.
Yeah, please join because it's their call. I think we're easily talk about this for 20 minutes, if not a bit more, with some more data to discuss.
Sweet. Anything else on Denkun or the forks or the testnets? Okay, next up, Andrew, you wanted to bring up the whole strategy around Verkle and state expiry. Do you maybe want to take a minute to chat about what questions you wanted to get into? And then we have I believe Guillaume, Josh on the call have been working on Verkle, and then Vitalik, I think, is also here. So yeah, we can probably hear from them. Yeah. Oh,
right, sure. I'm sorry, my connection is unstable, so I might break. But briefly speaking, like to my mind, state expiry makes sense because, well, for obvious reasons that with bigger state, the sync time goes up, but also like even disregarding the sync time, with each access, the bigger the state, generally, like roughly speaking, it's like the cost is logarithmic, and also like there are just so many dust accounts, things that are irrelevant. So just suboptimal to keep never clean the state. So yeah, and I'm a big fan of both Verkle and state expiry, and Vitalik's proposal makes a nice plan how to achieve both. As far as I can tell, the only thing, like the only problem is that address expansion. It's not like that was designed to help with the state expiry, which might be technically challenging to have this address expansion. But to my mind, that's a separate discussion. If we decide to have state expiry, then we need to like maybe rethink whether we need to whether we achieve that with address expansion or somehow else. But I would rather have both Verkle and state expiry.
Got it. Thanks. Guillaume?
Sorry, can you guys hear me? Yeah.
Yeah.
Yeah, I mean, I agree. The question that I'd like to understand, or at least the point I'd like to understand if you're making, or yeah, I'd like to understand the point you're making, sorry. Are you saying like we should have, Verkle or stateless and state expiry at the same time? Because, the current upgrade path does not preclude getting state expiry later, right? So my understanding is that you want both at the same time. And I have an issue with this because state expiry has been effectively abandoned as a research topic for the last 2 years. That would push, waiting for it would push Verkle back for at least a year, if not more. And we have some kind of ticking clock in the meantime, which is the state is growing. And that means the more we wait, the more the conversion will take time. So I understand that if we switch to that scheme that Vitalik proposed, and I think is has a lot of things going for it, namely that you don't really need to do the conversion live. So it would be actually not such a big problem. Like it would not be such a ticking bomb. But the way I see it is there's been efforts to get it implemented. There's been several in 2019, if I remember correctly, and also in 2020. They've both been abandoned. So yeah, I don't see, like at the current state of research, which, like I said, is abandoned. It's more like we're writing a blank check, and we hope that there will be state expiry implemented in the future. Yeah, this way, if it turns out this is abandoned a third time, we find ourselves with having to perform the overlay transition, except it's done a year later. So the amount of data that needs to be translated is even higher. So yeah, basically the question is not whether, in my opinion, it's not whether we should choose between statelessness and state expiry, but if we should do them at the same time. My favorite answer is no. But if you think differently, I'd like to understand why.
Oh, I think Andrew dropped and came back while you were talking. Andrew, are you back, Andrew? Andrew.
Yeah, sorry, I'm back, but yeah, I missed the last part. So is there a question? What's the question?
Yeah, I guess the question is trying to understand if you are you arguing for state expiry to happen eventually, or for it to be coupled with the transition to Verkle tree and say the same hard fork?
Oh, all right. No, but not. But I wanted to happen eventually, but it affects Verkle because if we decide that it happens eventually, then we can follow Vitalik's proposal and not bother with translating parts of the Merkle-Patricia trie with every block. That's how it affects Verkle. It actually simplifies. So
Oh, you're really breaking up.
It simplifies our transition to Verkle. Yeah, sorry. So if we do it eventually, we just need to do piecemeal translation, and just we don't like if state expiry happens eventually, then we can introduce Verkle.
Yeah, I think I understood the gist of what you tried to say, but you're breaking up quite a lot. Dankrad, I assume that's what you wanted to respond to.
Yeah, sure. So I think it's definitely still open that we will do state expiry eventually, but I think we should also. So there is also basically the option that statelessness goes well, like we achieve all the goals with Verkle, and very few nodes in the end opt to have the state because we find a good way of providing the state through other means, for example, like secured RPC node with let clients proofs, as well as I don't know, like something like Portal Network, and in that world, it seems like state expiry would become, at the very least, much less urgent and would be like a potentially long-term future thing. And in that world, carrying around the old Merkle-Patricia tree would make Verkle in many ways significantly worse and more complicated. And that is why eventually we opted like that this is pretty unelegant and that it would be best to just do the full Verkle. And even in the state expiry world, that's still better because there's no old MPT that's still carried around. So I think we should stay with this current roadmap, which is simply to like have a full transition to Verkle that makes no assumptions about future state expiry, which is still possible. And the question to do state expiry eventually, which is still quite a difficult problem, especially because it's coupled with address space extension. Yeah, so we make no prejudgment about that, whether it happens or not.
Got it. Vitalik?
Yeah, I guess I thought I would just give a bit of a background as to like why some of like we first thought about doing Verkle and state expiry at the same time, and then why we like ended up switching, and like some of the various nuances around all of those issues. So at the beginning, right, we thought about Verkle trees, and Verkle trees are important because they allow us to have witnesses that have bounded size, which makes stateless clients possible. It actually also reduces worst case bounds for ZK EVMs by quite a bit, because like if you have a 400 megabyte witness, that would also be in 400 megabytes of hashing at a ZK Sadark. So it's something that we probably have to do anyway. But the challenge with Verkle trees is one, the transition process, and the transition and then two is that like they don't solve the full problem because there's still a few nodes that have to have the entire state, right? So with the transition process, the issue is basically that like converting a 50 plus gigabyte Merkle patrician tree into a 50 plus gigabyte Verkle tree in a live network is just friggin' complicated. Like, this is something that the research team like literally agonized on for more than a full year. Like, I remember, like last year at DevConnect, it was basically the topic at the research event, and like it's basically as much R&D effort as the entire rest of the Verkle roadmap put together, probably. Like, just the process of how to do a live transition, like it's literally comparable to the merge in terms of complexity in some ways, right? And so it's pretty like it ends up breaking a lot of assumptions. Like, either you have to do some really complicated like thing where nodes sync two states at the same state roots at the same time, or you have to bring in trust assumptions, or nodes that are fast syncing during the transition process will have to have custom code to download two trees, and so on and so forth. And so with state expiry, like the natural attractiveness of this, right, is basically that whole complexity goes away, because you basically say, well, the epoch 0, or I guess the era 0 tree, since epoch means something else now, the era 0 tree is a Merkle patrician tree. Then we start era 1, new state goes into era 1, and then after 1 year, new state goes into era 2. And actually, we don't have to keep the MPT around forever, because what we could do is, once we're in era 2, then we can actually go and just do an offline computation and just in place swap the MPT root of era 0 with a Verkle root. And that actually ends up being significantly easier than doing a live transition, right? But basically, yeah, because just the form factor of state expiry does make it significantly easier to like do these two at the same time, or other, and like it basically removes the transition complexity, and it does, of course, add all of these other transition complexities involving address space extension. And I think the problem of address space extension itself might even be like complicated enough to be to have by itself been decisive in terms of putting things off in terms of the research agenda, right? Because like, just to like give an idea of this problem, basically, right now we have 20 byte addresses, but then if we're going to have these new eras, then the whole point is that objects that are created during these new eras would be in spaces that cannot collide with the existing 20 byte address space. Because if you see one of those objects in the state, then like you know that it's actually new, and you know that you don't need to like scan proofs for like absence of some other edit record in the past, right? And so, but the problem is that pretty much all existing contracts make huge assumptions all over the place about addresses being exactly 20 bytes long, and doing that would like getting around that would just require an unprecedentedly insane ecosystem level wide amount of work. And like, if we have the capability to do that amount of work, then personally I would like, there's like 5 other things that are higher priority in terms of the good that they could do for the Ethereum ecosystem, right? Like like getting everyone to switch over to like account abstraction, getting all the dApps to support ERC 1271 and ERC 6900, like getting everyone to use to be standards compliant, so non-MetaMask wallets would stop breaking. Just like this, incredibly long list of stuff that requires that same level of ecosystem level wide coordination. And moving from 20 byte addresses to 32 byte addresses is like literally that level of a task and crazier, right? Like, even ERC20 contracts would have to be redeployed, right? Like, there's huge amounts of code that for optimization purposes assume that an address is 20 bytes and try to pack something together with an address within one storage slot. So it's now there is one other possibility that's kind of less well known that I suggested, which is address space contraction. And there, the idea basically is that we ban 1 over 2 to the 32 of the address space from being used right now, and then we start using that in order to make in order to create address spaces for new eras. And if we do that, then like that actually completely solves the problem. But that has this like one really important big sacrifice to it, which is that counterfactual addresses that are multi-user stop being secure. So there's this fairly small but somewhat difficult to understand subset of applications that are kind of small right now, but might become significant in the future that stop working. But like it's the sort of like security weirdness that I think like rightfully sort of like perks security people's ears up in terms of just like bad things that could happen, right? Like we like security practitioners and devs and cryptography people just don't have experience dealing with hashes that are pre-image resistant but not collision resistant, which is effectively what we get if we use address-based contraction, because the hash part of an address would only be about 15 bytes. So that's basically in terms of address-based contraction for links, I think I wrote about this on ETH Research. I think if you just like search on ETH Research and like maybe address-based contraction or something, it might be in there. Right, but basically it's like there's these two proposals, and I think things kind of got stuck because they're for both of the, like one of them is just very hard, and the other of them is very is kind of imperfect in a different way. Though one thing that's worth noting is that we probably can't keep kicking the can down the road on this forever, because as of today, the security that we have on address collisions is 2 to the 80, and we are over the next, a couple of decades, gonna get into the regime where like doing 2 to the 80 compute power to create an address collision is gonna be start to become open to more and more people. I mean, technically it's doable already, right? Like in its history, the Bitcoin network has done something like, I think 2 to the 93 work or something like that. So, right, no thanks, Tim, though. Yep, that's the one. So it is something that we have to address anyway, but it's like a very thorny problem, and like extension and contraction both have their issues. And the one of the other kind of things with Verkle trees is that if we do the like a Verkle tree transition and we bite the bullet and we like actually do the complexity of implementing just a pure Verkle tree transition as a transition, then I think the downsides of delaying state expiry by literally another decade go down by quite a bit, right? And the reason why they go down is because even though it's true that the state size is going to keep blowing up, and at some point people are probably going to complain and ask to increase the gas limit, and at some point the gas limit's going to go up to like 40 or 50 million or something, and the state size will grow up faster, and the state will be a couple of terabytes, but the portion of nodes that would actually have to have the state is going to be much smaller. And even validators, like the nodes participating in proof of stake, would be able to be stateless with the combination of Verkle trees and the proposer-builder separation, including both like enshrined PDFs and the current MEV boost based stuff, plus a couple of like fairly I think small modifications that are totally manageable. You'd have to do a little bit of extra work to make inclusion lists work, because you'd have to make transactions carry proofs with through the mempool, but like that's totally doable, right? But like the point is that with that infrastructure, the number of nodes storing the state goes down by quite a lot, and like the amount of people who suffer if the size of the state literally blows up to 4 terabytes is going to be much lower. And so if Verkle trees exist, and the urgency of solving the state problem just decreases quite a lot compared to the urgency of like all of the various other stuff that like the EIP enthusiasts have down the pipeline, plus the like the urgency on the developer side to kind of just be cautious and continue to improve client quality and all, and make the existing chain work more efficiently and all of those things. So I think just kind of summarizing all of those different considerations put together, like it does feel like a bit of a binary decision in that either you do state expiry quite like basically with the Verkle transition, or if that doesn't happen, then like it's okay to just wait a decade and do state, or at least 5 years, and do state transition kind of fairly, or do state expiry like fairly far down the pipeline after that. Like it's the middle path, like doing state expiry somewhere like 1 year or 2 years after Verkle trees, that probably is unfortunately a bit of a worst of both worlds, right? So I think that's roughly the consideration, and I think it just depends, like how much we are concerned by the like issues involving a growing state. Another thing, actually, I feel like I might have sort of misspoken a bit, right? Like when we talk about things like complexity of state syncing, like doing state expiry also will require changing a lot of that code, right? Like it's not like doing the state transition, or it's not like doing a Verkle plus state expiry transition at the same time is easier than doing just a Verkle transition, right? I think it's maybe like it's definitely much less hard than doing the two transitions separately, but it's still like more work than doing one of those transitions, right? So we're not going to like save time by I think realistically by going straight to state expiry. So the question is just how much or do we value feeling like we have the state problem completely solved versus being okay with this kind of equilibrium where we like rely a bit on like proposer builder separation and the portal network and like some smaller number of state holding nodes and all of those kinds of things. Does doing SC plus VT together mean we don't need ASC and C? No, you still need address space extension or contraction if you do state expiry and Verkle trees together. If you want to do state expiry, you need to solve the address space problem at that time, regardless of what format you do it in, right? So if we want to do state expiry now, then basically we have to just like bite the bullet on one of the two address space solutions and commit to biting that bullet like basically literally now so that developers can start preparing for it.
Got it. And so I guess I'm trying to understand, you said the middle ground is the worst. I'm trying to understand why would doing them together actually be like, what is the like, so I guess we wouldn't need the live transition by doing them together, which simplifies it.
Right.
From what I understand of the work that's been done on Verkle trees so far, it seems like we're actually doing okay with regards to like designing your live transition and like improving on that. So I don't know how far along we are, but it, definitely more than zero.
Yeah, I mean,
yeah.
Right, but like we're doing okay, but just as a fraction of complexity of the entire Verkling project, it's surprisingly high, right?
Right. Yeah. But it's like, I guess we've already sort of accepted to bite that bullet and go down that path versus address space extension is basically in the same spot it was like 2 years ago.
Right, that's fair. I think
I just want to make sure that's actually the case. Yeah.
I guess one of the variables there that I don't know is like what % of the cost is sunk. Like, are we talking about 80% of the work being done? Are we talking about like 45%, somewhere in between, something even lower?
Yeah, Guillaume, do you want to maybe walk us through? I know we covered this a couple calls ago, but do you want to maybe sort of rehash where we're at with Verkle and specifically the transition?
Sure. Yeah. Well, I mean, okay. The problem is always that there's exactly what just happened when some design people agree on the design and then people just start paying attention and come up with a new design. But I mean, the way I see it, which is really just I'm speaking for myself here. We have like the implementation of Verkle tree in 2 clients, 2 and counting. There's Ethereum JS also that has made some progress, and I don't exactly know where Besu is exactly these days, but they also started working on it. Regarding the transition, so we at some point there was an agreement on the overlay method. This has been implemented. This has been tested. We have numbers. It looks like it's at least a workable solution. We are still discussing pre-image distribution, and there's been some back and forth about some details of the transition. Like, should we keep the MPT frozen, or should we keep writing to it? I mean, this is a discussion for another time. But so is it completely done? No, this is definitely more than 50% done. This is I would say 90% done. Of course, there's the question of like I said, pre-image distribution. So I think at this point it's yeah, there's got to be a good reason to change the transition method. But yeah, like you said, last 10% is 19%, 90% of the work, obviously, and that's quite true. Although, yeah, I think we're closer than than that. But yeah, I mean, okay, like I said, some people will disagree for sure. I think we have a pretty clear path, and now it's just about implementing the last few details and getting people to try it out.
Got it. Thank you. And I assume, just to be clear as well, I'm not aware of anyone who's worked on like address space extension or compression like significantly in the past year or two, but does anyone know of some? Yeah.
I mean, one thing I think I want to stress is that it might be worth revisiting in the just for kind of future compatibility reasons in the context of EOF, because there may well be decisions that we can make with EOF while EOF is not yet released that might make it significantly easier for us to do address space things in the future.
Got it. Andrew?
Yeah, I just wanted to note that we don't have to make any decision now, but I think I don't agree with Guillaume's argument that the Verkle tree is mostly done. So like how I heard it, then we should ship it, but we should ship what strategically makes sense, right? So we need to think about like what we do strategically about state expiry, and based on that, we that might shape how we ship Verkle, and that's all right. That's my point.
Right. And yeah, I think that makes sense. Like trying to, and I guess it's maybe just sharing the like mental journey that the Verkle people have been through, and like how Verkle fits in those parts of the roadmap. And obviously like if the explicit assumption is like we just put state expiry on hold for a long time because we rely on EPBS, basically on the builders to provide the states and whatnot. Yeah, maybe it's just worth making that a bit more explicit. Sorry, Josh, let me just read your question. Right, yeah, so how much extra value do we get by shipping state expiry at the same time rather than only getting Verkle ASAP? Yeah, I don't know if anyone has thoughts on that. I guess maybe one last question for Guillaume, Denkrad, and folks. What's the best place for people to just chat about stateless and Verkle on like a more regular basis? There's a Verkle try migration channel on Discord. Is that the main spot that people should follow?
I think there are state expiry and address space extension channels somewhere in there too, right?
Oh yeah, there's a space expiry channel or state expiry is pretty dead, and yeah, Do we still have the address space extension shadow? We might. Oh yeah, we do. Okay. Okay, so those three. Yeah. Oh, address space extension hasn't been used in over a year. Yeah.
But yeah, I mean, I do think that there's value in just like putting a team to think about the address space issue, because like it has a lot of future optionality value. And as I mentioned, like even if we never do state expiry, the whole like 80-bit address collision complexity thing is like a bit of a long-term ticking time bomb that's worth starting to figure out how to defuse.
Yes, if you're listening and you want to take this on, please reach out, and yeah, we can probably help set up a grant and put you in touch with the folks who looked at this in the past. Andrew, you still have, yeah.
Sorry, I just wanted to finish answering your question. There's also a Verkle implementers call where we discuss this kind of stuff. The next one is next Tuesday, I think. So yeah, that's usually a topic we talk about
Nice.
the transition.
That's good. And Andrew, did you want to add anything else?
No.
Okay. Anything else on this? Okay. Yeah, I think this was good to bring up and get everyone a bit more context around where things are at. Next up, Ethan, you wanted to share some updates on SSZ.
Yes. So SSZ has been standing still for a while, but I could finally find some time to update it. From last time when we discussed it, we essentially had two different approaches, one based on SSZ unions, where each transaction type, so to say, has its own branch in the object, and a normalized one where each transaction gets converted to a unified representation. So now what I did is essentially combine those two approaches into something called a partial container. So how this works is that essentially it behaves like the union when it comes to serialization. It is very close to it, a little bit different in the header, but the rest is exactly the same. But it also ensures that when there are common fields in the transactions, which there are a lot, for example, the amount is present in every transaction type so far, or like the destination, those common fields, they now Merkleize always at the same location in the tree with this new approach. So there can be holes now in this partial container. So if one transaction type doesn't use a certain field, in the Merkle tree, it simply becomes a 0. And this ensures that we essentially get all the benefits of the union without requiring any clients that verify Merkle proofs to update each time there is a new transaction type. Like they can just continue to keep the same verifier forever unless they start caring about the new fields. So yeah, that's the latest approach there. I have also extended the specifications for networking. So with the previous approach, the SSZ transaction was only something that gets created as part of the execution payload. But with this latest specification, you can also directly sign SSZ transactions and put them in the mempool and everywhere. Because of this flexible container, it is possible with the SSZ transaction to just mix and match your own fields. I have somewhere is a police car. It's not for me. It's somewhere else. So I have made sure that there is like a little function that checks the invariance so that no new combinations are possible. So for example, if you include a blob, then you also have to include the destination and you have to include the priority fee. So no new transaction types. But everything that's possible right now, with the exception of the replayable legacy transaction, is now also possible with SSC transaction, exact same feature set. Yeah, so just want to raise some awareness there to check out the EIPs. I have put them in the PM issue on GitHub. And would appreciate reviews. And also, if there are any questions, the typed transactions channel on Discord is the one for questions.
Thanks. Yeah, anyone have any questions or comments they want to bring up now? Okay, well, yeah, thanks, Ethan, for the update. And then I think that was basically it. Was there anything else anyone wanted to cover? If not, I'll just give a quick shout to EELS. So the EELS team officially put out a blog post announcing the Python spec for the EL this week. So the spec's been live for a while, but I think now it's call it production ready. There's also a PR from Guillaume about the self-destruct removal that he opened and that you can contrast with the original EIP. So that shows kind of a nice, a nice side-by-side implementation in both EELS and in a regular EIP. So if people want to use EELS to write EIPs, you can, and you can even link to it in your EIP, and the bot won't stop you. And similarly, so the yellow paper came up a bunch on Twitter in the past few weeks. People were linking to it. So I figured it was worth a quick update, but just as a heads up, the yellow paper hasn't been updated since Berlin. So if you look at it today, you basically see the Berlin spec. If someone wanted to update it and add support for London and Paris and all the difficulty bomb forks in the meantime, there's the option of a grant for that. And we've linked this in the yellow paper repo, and also are pointing people towards EELS there as the up-to-date spec for mainnet. I don't know, Guru, did you want to add anything more around EELS?
No, not much. You covered most of it, Tim. So, like, any PRs on new EIPs are welcome. We would also like some feedback on like how easy or smooth the process is, and yeah, we would like to continue to work on like solving any issues that people might encounter. So, feedback very much appreciated.
Sweet. Anything else before we wrap up? Okay, well, thanks everyone, and talk to you all, whatever the next call is, testing call on Monday. Yeah, thanks.
Thanks, bye.
Thank you.
Bye-bye.
Bye.
Thanks.
Bye.